Let's look at the general term of an AP. Consider the following AP. Here, A is equal to 5 and D is equal to 3. First term is equal to A is equal to 5. Second term is equal to 8 is equal to 5 plus 3. Third term is equal to 11 equals to 8 plus 3 and so on. This AP starts with 5 and jumps 3 every time. It does not help us to calculate the 10th term, the 15th term, the 100th term, in general any nth term. So, we must have a formula to find out any term, say nth term, which gives an expression for the general terms in terms of n. Thus, by substituting value of n as we wish, we can find any term. This gives an expression for the general term. Derivation of the formula for the general term. Consider the AP A, A plus D, A plus 2D, A plus 3D and so on. Here we have T1 is equal to A. Let us mark it as 1. T2 minus T1 is equal to D. Let us mark it as 2. T3 minus T2 is equal to D. Let us mark it as 3. In general, we can write as Tn minus 1 minus Tn minus 2 is equal to D. Let us mark it as n minus 1. Tn minus Tn minus 1 is equal to D. Let us mark it as n. Adding all the n equations, we get T1 plus T2 minus T1 plus T3 minus T2 plus up to Tn minus Tn minus 1 is equal to A plus D plus D plus D up to D into n minus 1 times. Therefore, Tn is equal to A plus n minus 1 into D. Thus, the nth term of an AP with the first term as A and the common difference D is given as Tn is equal to A plus n minus 1 into D. For an AP, if D is equal to 0, then the sequence is a constant sequence. Example 1. Show that the nth odd natural number is 2n minus 1. Solution. The list of odd natural numbers is 1, 3, 5, 7, 9 and so on. This is an AP with A is equal to 1 and D is equal to 2. We know that Tn is equal to A plus n minus 1 into D. Here, Tn is equal to 1 plus n minus 1 into 2 is equal to 2n minus 1. Therefore, Tn is equal to 2n minus 1. Example 2. Find n if the nth term of the sequence 5, 8, 11, 14 and so on is 68. Solution. The given sequence is an AP with A is equal to 5, D is equal to 3 and Tn is equal to 68. Tn is equal to A plus n minus 1 into D. Therefore, 68 is equal to 5 plus n minus 1 into 3 is equal to 5 plus 3n minus 3 is equal to 3n plus 2. 3n is equal to 66. Therefore, n is equal to 22. Let us solve exercise 1.3. Number 1. Find the 25th term of AP 12, 16, 20, 24. Solution. Tn is equal to A plus n minus 1 into D. Here, A is equal to 12, D is equal to 16 minus 12 is equal to 4. T25 is equal to 12 plus 25 minus 1 into 4 is equal to 12 plus 24 into 4 is equal to 12 plus 96 is equal to 108. Therefore, T25 is equal to 108. Number 2. Find Tn for an arithmetic progression where T3 is equal to 22, T17 is equal to minus 20. Solution. T3 is equal to 22. T17 is equal to minus 20. Tn is equal to a plus n minus 1 into d. T3 is equal to a plus 3 minus 1 into d. 22 is equal to a plus 2d. Equation 1. T17 is equal to a plus 17 minus 1 into d. Minus 20 is equal to a plus 16d. Equation 2. Subtracting 2 from 1, we get minus 14d is equal to 42. Therefore, d is equal to minus 3. Substituting d is equal to minus 3 in 1, we get 22 is equal to a plus 2 into minus 3. 22 is equal to a minus 6. Therefore, a is equal to 28. Therefore, Tn is equal to 28 plus minus 3n plus 3. Tn is equal to minus 3n plus 31. Number 3. For an AP, if T4 is equal to 12 and D is equal to minus 10, find the general term. Solution. T4 is equal to 12 and D is equal to minus 10. T4 is equal to a plus 4 minus 1 into d is equal to 12. T4 is equal to a plus 3d is equal to 12. 12 is equal to a plus 3 into minus 10. 12 is equal to a minus 30. A is equal to 42. Tn is equal to a plus n minus 1 into d. Therefore, Tn is equal to 42 plus n minus 1 into minus 10 is equal to 42 minus 10n plus 10Tn is equal to 52 minus 10n. Therefore, general term Tn is equal to 52 minus 10n. Number 4. Given the following sequence, determine whether it is arithmetic or not. If it is an arithmetic progression, find its general term. The sequence is minus 5, 2, 9, 16, 23, 30 and so on. Solution. T1 is equal to minus 5. T2 is equal to 2. T3 is equal to 9. T4 is equal to 16. Difference between consecutive numbers. Minus 5 minus 2 is equal to minus 7. 2 minus 9 is equal to minus 7. 9 minus 16 is equal to minus 7. This shows that the difference between any two consecutive terms is constant. Hence, the given sequence is an AP. A is equal to T1 is equal to 5. D is equal to minus 7. Tn is equal to a plus n minus 1 into d is equal to 5 plus n minus 1 into minus 7 is equal to 5 minus 7n plus 7. Tn is equal to 12 minus 7n. General term Tn is equal to 12 minus 7n.